Okay, guys, welcome. Today we're going to talk about exponential and logarithmic equations. Okay, now to solve exponential and logarithmic equations, you're really going to be utilizing the exponential and logarithmic forms, right? So if you have a to the x is equal to y, we know that that's equivalent to log base a of y is equal to x, right? So we're going to use that a lot. Now, to solve an exponential equation, your first bet is to try and rewrite both sides with the same base. Now, if you can't do that, that's when you're going to use logarithms on both sides of the equation. You're going to take the log of both sides, or if you only have an exponent on one side, you can just simply convert it to logarithmic form. Now, to solve a logarithmic equation, you're going to bring all your logarithms to one side and condense, and then you'll convert to exponential form. All right, so let's do a couple of examples of that. So in part A, you have 3 to the 2x minus 1 is equal to 17. Right? Now, I can't write 17 as a power of 3, so I have to use logarithms here. Right? So what we can do is let's go ahead and, since it's only has an exponent on one side, let's convert this to logarithmic form. So if we convert this, this is log base 3 of 17 is equal to 2x minus 1. Well, now I just need to add 1 and divide by 2. So I'm going to get log base 3 of 17 plus 1 is equal to 2x. And then if just divide both sides by 2. So we get that x is equal to log base 3 of 17 plus 1 over 2. Now, of course, we can't do log base 3 of 17 in the calculator, but if I think of this using the change of base formula as a log of 17 over log of 3, then we can do it. All right, so that's what we're going to do. So let's go ahead and let's just type this into the calculator. So if I do log of 17 divided by log of 3, I get some gross number for that, and then I add 1 to it, and then I divide it by 2, and then I get that x is roughly equal to 1.789. All right, so again, don't let the fact bother you that you have logs in there, because that's just some number once you type it out in the calculator. Now in part B, we have to be a little bit more clever, because we have 2 to the x plus 1 is equal to 3 to the 2x minus 3. Now here we need to take logs of both sides, right? So let's just take a log of both sides. Now, why would we do that? Well, the whole point of doing that is so that I can take this power out front. I'm not going to get x plus 1 times log of 2, and then that equals a log, sorry, I'm going to get a 2x minus 3 times log of 3. All right, so now we have x's on both sides. So let's go ahead and distribute, and then we'll get x by itself. So if we distribute, log 2 times x is just log 2x. Log 2 times 1 is just log 2. Right? Then on the right side, we're going to get a 2 log 3 of x minus 3 log of 3. So now let's get all of our x's to one side. So I'm going ahead and subtract this from both sides. And again, this is log 2 times x, not log 2 of x, right? And this is log 3, 2 times log 3 times x. And this is just log 3 and log 2. All right, so be a little bit careful there. So now I'm going to subtract log base 2, sorry, log of 2 times x, and then I'm going to add the 3 log 3 to both sides. right? So now what happens is that this cancels, and so does this. And now on the left side, we have a log base 2 plus 3 log base 3. I keep saying base, but it's not. And then on the right side, we have a 2 log of 3 times x minus log of 2 times x. Well, now on the right side, I can factor an x out, and I'm going to get x times 2 log 3 minus log 2. And still equals, and if I combine these, I can bring this 3 up here, and this is going to be a log of 27, and then if I combine them, it'll be a log of 54. Right, so this is using log properties. Right, and that's just me. You could still leave it as log 2 plus 3 log 3, but I don't want to have to write it out every time, so I'm just combining it. Right, and you could even combine the stuff on the right side too, but if we divide both sides by log 2 log 3 minus log 2, we're going to get what we want. So if we type this into our calculator, if I do log of 54, oops. So I want log of 54 divided by a 2 log of 3 minus log of 2. I'm going to get that x is roughly equal to a 2.652. All right, so that one is a little bit more gross, but again, we didn't really do anything that hard. We took a log at the beginning to get rid of the powers, right, so that they came out front. And then the rest of it was just algebra. It was just messy because we had logs in it, right? But so we get x is equal to 2.652. Okay, so let's solve this log equation. So now remember, the goal for a log equation is to get all the logs by itself on one side, so we have a single logarithm. So then on the right side, we have 1, and on the left side, we have a log of a 2x plus 8 over, oops, let me not do that yet. And then this is minus log of x minus 4. Right, but of course we want to convert, so this is a log, sort of what was starting to do, 2x plus 8 over x minus 4 is equal to 1. And now we can convert this. This is a log base 10, so this is 10 to the first is equal to 2x plus 8 over x minus 4. So now let's clear the fraction. Let's multiply both sides by x minus 4. So then we're going to get a 10x minus 40, once we multiply by 10, is equal to 2x plus 8, and the x minus 4 is just canceled. So now if we bring our 2x over here and we add our 40 over here, we're going to get that 8x is equal to 48. So we're going to get that x is equal to 6. Now here you have to be careful, because since you have logarithms, you can only plug in positive numbers, right? Now I shouldn't say you can only plug in positive numbers, but whatever's in parentheses for the log better be positive, right? But here we're okay, because if I plug in 6, all logs are still positive. So good. Right? If you had a number that resulted in the inside of a log being negative, then you'd have to throw that one out. Okay, let's do another example. So here, let's add log base 2 of x plus 2 to both sides. So here we'll get a log base 2 of x plus log base 2 of x plus 2 is equal to 3. So now we need to condense this, and we're going to use the multiplication rule. So this is log base 2 of x times x plus 2, and that equals 3. So now if we convert, this says that 2 to the third is equal to, once I distribute, x squared plus 2x. So we have a quadratic, so let's move everything to one side. So I have 0 is equal to x squared plus 2x minus 8. So that we can factor as an x plus 4, x minus 2. So this gives me that x is negative 4 and x is equal to 2. Now we have to check both of these. If you have negative 4 going in, then right away this is bad, right? Because you get a negative log. So this gives negative inside a log. So throw out. Okay, now I want to be clear here. It's not the fact that we have negative 4 is automatically bad. It's that when we plugged in negative 4, we got a negative. That's what made it bad. Now, if you check 2, we get a log of 2, so that's fine. And we get a log of 2 plus 2 or a log of 4, so that's fine. So 2 is good. All right. So it's only if plugging in results in a negative. It's not necessarily that the x value itself was negative. Okay, so the next example, we want to suppose that the world population is described by an exponential growth model in which the growth rate is 2.5% per year. We want to know in how many years will the population double, okay? Now, remember that from a previous video, the exponential growth equation is q of t is equal to q0 times e to the kt. Now here we have that our growth rate is 2.5%, so that means that k is 0.025. Now we're not given an initial quantity, but we want to know when this will double. So we want to know when q of t will equal 2 times q0. So this means that our equation is 2q0 is equal to q0 e to the 0.025 times t. Right? Well, we need to solve for t, so let's divide both sides by q0. And then we have that 2 is equal to e to the 0.025 times t. Well, now we have an exponential equation with the exponent on just one side, so let's convert to logarithmic form. And this says that we have a log base e, which is a natural log, of 2 is equal to 0.025 times t. So we're going to get that t is equal to ln of 2, because that's the same thing as log base e, divided by 0.025. So it looks like here we're going to get for t whatever ln of 2 divided by 0.025 is, and that will give us that t is 27.73 roughly. So we'll take about 27 3/4 of a year for this initial amount to double, right? Okay. Last but not least, we have that a trust fund invests $8,000 at an annual interest rate of 8% compounded continuously. We want to know how long will it take for the investment to grow to 12,000. So again, compounding continuously is A equals P times e to the RT. And here we have that A is 12,000, P is 8,000, and then we have e to the 0.08 times t. So we want to solve for t, so let's divide both sides by 8,000. So we get a 3 over 2 is equal to e to the 0.08 times t. And then same idea, we want to convert this to logarithmic form. So we have a log base e, which I'm just going to write as natural log of 3 over 2 is equal to 0.08 times t. So now just divide both sides by 0.08. And we're going to get that t is equal to whatever ln of 3 over 2 divided by 0.08 is. And if we do that, we get that t is 5.067 So it's going to take a little bit more than 5 years for this investment to grow from $8,000 to $12,000. All right, so that's the last example. So I hope you enjoyed, and I will see you next time.